All right. Hey, everyone. It's Ms. Turk here with your 6.1.3 Semester 1 exam to give you some hints, and also I'm going to cut out some of the questions on this. All right. All the stuff about Aristotle you can find, let's see, the first one you can find in 1.2.1, page 8, and then the second one you can find in 2.1.1, page 3. The stuff about John Dalton and the conservation of matter was in 2.1.1, page 10. All the stuff about J.J. Thomson was 2.1.1, page 4 to 6, and Ernest Rutherford 2.1.1, page 10 to 12. On to the periodic table part. This you should get out the periodic table I sent you because all the stuff is very clearly laid out on there. So the atomic number, the average atomic mass, and the valence electrons. And in case you forget, the atomic number is the one on top, average atomic mass is on the bottom, and the valence electrons is this number at the bottom of its group. For the neutrons, you can look at 2.2.3, page 13 to 17. If you don't remember what a family is, 2.3.1, page 10. The full electron configuration of fluorine. I would not recommend looking in the text for this because they didn't do a good job of explaining it. Just look on the back of the sheet I sent you, okay? And this will kind of help you trace your way through the periodic table to figure out the electron configuration. So we know that there's electrons in the first energy level and the second energy level for fluorine. Okay, fluorine has electrons in the first two energy levels because it's in period 2. So we know fluorine's over here. It's in period 2. So that means it has 2 occupied energy levels. But remember, those energy levels are then divided into sublevels called S, P, D, or F. So fluorine has 9 electrons, okay? So to figure out the electron configuration, you can just use this to trace your way up to number 9, okay? So first we have the 1s sublevel. That's 2 boxes, each one representing an electron. So that's the first electron, that's the second electron. So you'll start out as 1s, and that was 2 boxes. So there's 2 electrons there, so you put a 2 up high. Then you go to 2s, put the number of electrons up high, and then 2p, and put the number of electrons up high. And the numbers up high should all total up to be 9 because there's 9 total electrons in fluorine. C number 1, you can omit that about the radius. It's not that important. And you can omit number 2 about electronegativity. So don't worry about those. For the third one, fluorine's chemical properties, what do they resemble? Look at 2.3.1, page 10 for that. Intramolecular forces and bonding. I'm just going to tell you the answers to some of these because they are important, but the book did not clearly lay them out, I don't think. What happens to electrons in an ionic bond? They are transferred, okay? What happens to electrons in a completely covalent bond? They are shared, okay? So ionic is transferred, covalent is shared. And what is a polar covalent bond? That's a covalent bond where electrons are not shared equally, or they're shared unequally. Part B, this whole chart, you can omit that. For C, write the name if it gives you the formula, or write the formula if it gives you the name. Remember, if it's ionic, if it's a metal and a nonmetal, the name does not have prefixes. But if it's covalent, if it's all nonmetals, it does have prefixes, okay? So sulfur and chlorine are both nonmetals, okay? They're both on this side of the staircase. Remember, nonmetals are on the right, okay? So this is going to be covalent, so you're going to need to use prefixes. So look at the Greek prefixes right here, okay? Remember, if the first one is 1, you don't write mono. But if the first one is something higher than 1, you do write the prefix. If the second one is 1, you do write mono, like carbon monoxide. Or you write any of the higher ones as well, okay? So sometimes the first number doesn't have a prefix. That's when it's 1, but anything higher than 1, it'll have a prefix. The second word in the compound always has a prefix for covalent, okay? This one is ionic because it's a metal and a nonmetal. So this one's not going to have prefixes, okay? So you just name the metal, name the nonmetal, and change the ending of the second one to IDE. And then this one, iron is a metal, chlorine is a nonmetal, so this is ionic. Remember, to write an ionic compound formula, you need to crisscross the oxidation states. So figure out the oxidation state of iron 2. Okay, you can look on there. Figure out the oxidation state of chloride. That's just the negative form of chlorine. You can look right here. And then crisscross those charges to get the formula. 4A, you can omit that. 4B, so yeah, you don't have to do 4A at all. For this one, what evidence of a chemical reaction would you expect to see? I'm not sure how they would expect you to know this, so I'm just going to tell you the answer. You would expect to see a solid precipitate. You would expect to see a solid product show up that does not dissolve in water, because you're mixing two solutions. It's going to be a double displacement reaction, and one of the products will not dissolve in water. Okay, so to write the chemical equation, we're going to do CaCl2. Okay, and it's reacting with Na2CO3. Okay, and for double displacement reactions, write the charge. Sometimes it's helpful to write the charge above each one, or the oxidation state. So calcium is 2+, and chloride, each chloride is 1-, and there's 2 of them, so those charges add up to 0. Sodium, Na, is 1+, and then the CO3 is a polyatomic ion. So the CO3 2-, it's called carbonate. So this carbonate has a charge of 2-. So we have a carbonate with a charge of 2-, and then 2 sodiums with a charge of 1+. So in a double replacement reaction, they're going to switch what they're bonded with. The positive ion here is going to bond with the negative ion here. So the calcium will go with the carbonate. And then the sodium, this positive ion, will bond with this negative ion. Okay, so you should have 2 products. Okay, positive ion bonded to negative ion, positive ion bonded to negative ion. And be sure the charges add up to 0. Okay, and then balance the equation by putting numbers in the front. Okay, so once you have your products written down, you can balance the equation by putting numbers in the front. The type of reaction, like I said, is going to be double displacement or double replacement. All right, for part C, this is some stoichiometry. So they're telling you the amount of CaCl2 that you have, that you're going to start with. I'm not sure why they're saying it was melted. It decomposed. This isn't melting. This is decomposition. But in any case, what they're wondering is how much Ca are you going to produce in grams. So we're going to start with what we started with, okay? For here, you're going to figure out the molar mass of CaCl2. So you're going to add up the mass of a Ca and then 2 Cls from the periodic table. And you're going to put that's the grams in 1 mole. So whatever that adds up to, put it there. The mole ratio, whenever you see moles over moles, that's when you look at the coefficients, okay? So for this equation, all the coefficients are 1. It's just 1 CaCl2 yields 1 Ca plus 1 Cl2. So these are both going to be 1, okay? And then here you need to fill in the molar mass of Ca, okay? So that's the molar mass of Ca, and then that's the grams in 1 mole, okay? And then you can cancel your units, grams CaCl2, grams CaCl2, mole CaCl2, mole CaCl2, mole Ca, mole Ca, and we end with grams Ca, which is what the question's asking for. So be sure you multiply all the way across the top, write your answer down, multiply all the way across the bottom, write your answer down, and then do top divided by bottom to get your final answer. Okay. And then this last one, balancing redox. So this was in 5.1.3, page 4. Okay. So you're going to write the 2 half reactions. So one of these is going to be the zinc turning into the zinc 2+, and you need to figure out which side you need to put the electrons on and add them in. And then the other one's going to be the Fe3+ turning into just normal Fe. Okay. And keep in mind, these don't have a charge. These have a charge of 0. You can even put a 0 up high to remind yourself. So figure out where the electrons are going to go here, okay? And also figure out which one's oxidation and which one's reduction. So you can look back in 5.1.3 for help with that. Now we need to multiply. Then you're going to, in part B, you're going to need to multiply both of these by something so that the electrons cancel out. One of the equations is going to have 3 electrons. One of the equations is going to have 2 electrons. So multiply them both by something so you get 6 electrons in both equations, and that way you can cancel the electrons out, okay? And then once you cancel those out, you can add the equations together, and that'll give you a balanced equation. All right, so hope that helps with the 6.1.3 semester 1 exam.